Hi, my name is Aiman Ashab bin Badar Hisham, and today I will introduce to you what is hydraulic conductivity and also shear strength of waste. Alright, first of all, let's look on hydraulic conductivity of waste first. Govern the transport rate to leachate and other fluid or microbiological contaminants within the solid waste field. High moisture content causes low hydraulic conductivities. Depends on the density itself of the waste. Usually, shredded waste has hydraulic conductivities of 10 to the power of negative 4 to 10 to the power of negative 6 meter per second. Solid waste is not necessarily homogeneous, so the hydraulic conductivities are not isotropic. Let's move on shear strength. The shear strength of sludge in landfill usually is about 10. When co-disposed with dry refuse such as paper or cardboard, shear strength improves. Lastly, shortly after compaction, the shear strength to be the highest but decrease over time. Thank you.
My name is Nazra Akila, matrix number A825034, and I'm representing for 6.3.1 and 6.3.2. I will briefly explain collection, transfer, and transport in solid waste management. Collection is the process of gathering solid waste and recyclable materials from industrial, commercial, and residential areas. Common collections methods include curb or alley, pickup, set out and set back pickup, and backyard pickup. These methods ensure waste is collected efficiently and transported for further handling. Transfer and transport refer to moving waste from collection vehicles to larger transport vehicles at a transfer station. The waste is then transported to processing facilities of landfill sites. The main benefits of transfer stations are reducing transportation costs, minimizing traffic from smaller vehicles to landfill, and lowering labor costs by reducing waiting time. In conclusion, effective collections, transfer, and transport systems are important for maintaining cleanliness, protecting public health, and ensure efficient waste management. Thank you.
My name is Lanjai. Today I will like to present the solid waste disposal. For the Part A landfill, it was the most traditional method of waste disposal. Waste is dumped into disuse quarries, mini voids of borrowed pits, and is also compacted and covered with soil. Water layer normally is between 1 or 2 meter thick. Soil cover thickness normally is 20 cm. For the Part B sanitary landfill, it was controlled disposal of solid waste to minimize environmental hazards. Important aspects got like site selection, landfilling methods and operation, gas and litter occurrence, and gas and litter control. For the Part C, landfill operation methods, the first one is area fill. The advantage of the area fill is no trench excavation, handles high traffic, but the disadvantage is may require imported cover soil, higher litter problems. For the second one is trench fill. The advantage is better litter control, no need to import cover material, and the disadvantage is unsuitable for high groundwater areas. Excavation costs can be high. For the last one is depression fill. Normally it used for canyons, ravines, quarries, and borrow pits. Its filling starts from the heat end to prevent water accumulation. For the Part D, landfill environmental control, it can exclude hazardous waste, apply daily cover, control disease vectors, and explosion gas. Besides that, it also can protect surface water and groundwater, control run-on and run-off water, maintain operation records. For the Part E, leachate management option like leachate recycling, leachate evaporation, level treatment, it also can discharge to municipal wastewater system. For the last part, Part F, the main treatment methods, it was like gasification, pyrolysis, incineration, and waste autoclave. Now I would like to present the waste wash mustard content. You can see the formula. The MC is moisture content, and then the W is initial weight for sample, and then the D is weight after driving. It was estimate the moisture content and density of 100 kg solid wash sample with the following condition. For the sample step, we measure the initial weight, dry the sample, and then measure the dry weight, and then last one is apply the formula. Then we can find the answer.
Field capacity is the maximum percentage of volumetric soil moisture that soil sample can hold freely against gravity. Water in excess of field capacity will drain away as leachate. It is important to determine field capacity in order to limit the amount of leachate generation. So for sandy soil, the field capacity is about 5%, dry soil about 30%. For solid waste in landfill, FC decreases with overburden pressure, and for uncompacted municipal solid waste, it's about 50 to 60%. So the calculation for FC is 0.6 minus 0.55 bracket W over 4500 plus W close bracket, where FC is the field capacity, percentage of dry weight of waste, while W is overburden weight calculated at the mid height of waste in lift kg.
My name is Muhammad Fahmi Hakim Rostan, biometric AA251519. Now I want to discuss about particle size distribution. For this table show the particle size distribution of different MSW components. We can see we can see that paper and cardboard have a largest typical size at 350 mm, while HS does have the smallest size at 25 millimeters. The variation in particle size is important because it influences the waste separation and treatment process.
For my part, I will explain about chemical and energy properties in municipal solid waste MSW. There are three techniques used to determine the chemical properties. First is proximate analysis, which measures moisture content, volatile matter, fixed carbon, and ash. Second is ultimate analysis, and third is energy content analysis. Next, the energy value can be converted to a dry basis using the formulation, which removes the effect of moisture. Another equation is used for ash-free dry basis where both ash and moisture are excluded. The table on the right shows the inert residue and energy content for different waste materials. Plastic and rubber have high energy values, while glass and metal have very low energy content. Overall, different waste materials produce different amounts of energy.
Biological properties. Anaerobic composting is the biological decomposition of food waste with end product of methane, carbon dioxide, and others. Plastic, rubber, leather, and woods are undesirable for biological conversion. BF stands for biodegradable fraction expressed on viral type (BS basis). Meanwhile, LC, lignin content of BS, percentage of dry weight. So, BF equal to 0.83 minus 0.028 Lc. The highest biodegradability of various MSW components is food waste (0.82), meanwhile the lowest is newsprint (0.22).
Thank you to all my friends. To wrap things up today, I have three quick fascinating questions to see how well you know our topic. Let's find out who's the real expert in the room.